Aloha, this is ITS128, and so let me share my screen. And this is October 6th, and so we are right in here. We're starting Chapter 5 today. And so let's take a look at Chapter 5. Chapter 5, oh, here it is. And Chapter 5, loops. Okay, so just so you get the basic idea of loops, well, let's see. First of all, let's go back here. There are two basic kind of loop structures in Python, and one is a while loop, and the other is a for loop. And you'll be able to see the differences once we get into for loops, because with for loops, there's a bunch of other little features in there. So you can loop through stuff other than just saying 1, 2, 3, 4, 5, 6. You can have a string, a word or a sentence, and with a for loop, you can loop each character at a time, looking for something. Here we'll talk about while loops versus for loops, and then we're going to get into some more deeper stuff like when you nest loops. You can have loops inside loops, and you can break out of loops. And there's this one other thing called loop else, and which isn't used very often. But and then there's a bunch of labs here. And so what I'd like to do today is cover while loops. And so I'm going to cover while loops and do some challenge exercises, and then perhaps do a couple of the labs down here that where a while loop is the most appropriate loop to use for the answer. Turns out that well, you can always where there's a while loop, you can not so much a while. No. Where there's a for loop, you can replace it with a while loop. But where there's a while loop, sometimes it's more difficult to replace with a for loop. But you'll see that in a lot of cases you can use either, and it's a matter of style, and it's a matter of actually looking specifically at the problem and figuring out which one is more appropriate. So let's start out by just talking about loops here. And so here's a dumb example of a loop. And for those of you that have children or have maybe had a little baby brother or sister or something, you might. It depends on the baby, but here's a dumb example where some parents are coming home. Here, let's do this. You're coming home and your baby's crying, or your baby's awake, and what you want to do is you want to drive around until the baby falls asleep. And I think we did this when my daughter's 22 now, so it's hard for me to remember. But so in this dumb example, you would drive, and once you get to this intersection, you would say, "Is the baby awake?" And if the baby's awake, if it's true that the baby's awake, then you go this way and you come back around here again, and you come back up here, and you look again. Is the baby awake? It is. So you keep on going, and then you check again, and finally you check, and the baby's not awake. And in that case, you can drive down here and go home. So here's an example. So it checks again, and the baby is crying. So you notice it went around again. We'll do it one more time. And you check. Oh, okay. The first thing it does is checks. Right. With a while loop, the first thing you do is you check, and if the condition is true, then you do the loop. So that's a better. So let's look at this again. So it came down to here. It did the test. If the test was true, so then it went around the loop again and came back up here. And now we're at the point where we're going to make the test again. So we test again. Baby's crying, so we go do the loop again. Test again. Baby's not crying, so you can just go home. All right, great. So here's some example. Here's some questions to make sure you understood exactly. And there's this concept in loops. You first begin to see it in loops, and that's where you could be off by one. Where sometimes with loops, not in Python we don't see it so much, but sometimes you can test at the beginning of the loop, or you test at the end of the loop, or you want to go through the loop 5 times, and so each time you test, and sometimes you'll get your condition off just a little bit, and you'll end up doing the loop one more time than you thought you did, or you'll do the loop one less time than you thought you did. Those are very common errors when you're writing code that have loops. So it's kind of like you begin you very early on in your programming career, you look for those errors and you're careful for those errors. So anyway, so you can answer these questions. Here is an example of where summing input values. So here you're going to sum up. You're going to read in numbers, and you're going to read in numbers until you get a -1. So in this particular example here, you're going to read in a 2, then you're going to read in a 4, then you're going to read in a 1, and then you're going to read in a -1. And so here here at this point, okay, so here we get the first input, and then we test. If that value is greater than or equal to -1, as long as it's 0 or greater, then we're going to add. We're going to sum it. We're going to sum the value. Let me make this bigger. So you're going to sum the value, and then you're going to get the next input, and then you're going to go back around, and you're going to test the loop again, and if you read it in, and if it's not greater, or no, if it's greater than -1, while it's greater than -1, you do the loop again, and you add it, and you read up the next one. So so let's run this. What's going on? Okay, there it just showed us what a loop was. That's nice. Okay, here we go. Sum is equal to 0. Read in the 2. Is 2 greater than? Yes, it is. So come down here, add it to sum. Come down here, read up the next one, and so we read the next one, and now we're going to test it, and it is greater than -1, so we're going to add it again. We read in the next one, and come back around again. Okay, and we're going to now we've read in a 1, and now we're right here. We're going to test it. 1 is greater than -1. So go down here, add it to the sum, read in the next one, come back around here, and let's test it again. This time, -1 is not greater than -1, so it should just drop through. Just drops through. And what we end up with is the last thing that was added was the 1, which was added onto the 6, and the result is a 7. So right here we output it, and we end up with the 7 here. So that's an example of a loop. Here we're figuring out the average of a bunch of numbers that are read in. So we're going to read in a bunch of numbers here, and each time we're going to keep track of 2 variables. To figure out the average, you sum up all the numbers, and then you divide by the number of numbers that you read in. So we have to have 2 variables for that. We're going to have a variable that's the sum, and we're going to have that's the sum up that's adding up the numbers as they come in, and then num is going to count the number of numbers that we've read in. So so it's the same thing. We're going to the while loop is going to be true for 3 times, and then the last time the while loop is going to be false. So it'll not, so it won't take the loop. So if we, so here we set the sum, we set the num, we read in the first one, we check it's true, so we do the loop, and we sum it, we count, and we test again. Or no, now we test, add the value, count it, read the next one, and now it's 9. Do it again, sum it, count it, read in the next one, and then it's going to be, now this time the condition will fail, and we won't take the loop, so it'll just drop through, and we see that it drops through. Then it computes the average, and then it prints out the average. You can answer these questions. In the first example above, the first value gotten from the input was 2. That caused the loop body to be executed. Before the loop, the first input value is gotten. If that input was negative, the loop's body would not be executed, I think. Yeah. In other, we'll see if this, in some languages, the more common loop is a loop that tests at the end. So it's going to always take one pass through, and then it tests at the end. And so, one of the things that you want to decide is whether you use the kind of loop that tests at the beginning and tests at the end. We'll see what features. Each language has unique loop features, it seems, and we'll see that later on in this chapter. All right, counting specific values in a list. Okay, so in this example, increment if a negative value is seen. So in this example, we're going to read up a bunch of stuff, oh, this is a participation activity. Well, we're just going to count the number of negative values. And it's timing us, okay? We don't increment this. We're incrementing with negative values. So next value, negative, next value, next value, next value, negative, next value, negative, next value, negative. I guess it worked. All right. Okay, now the way you do these is complete the program such that the variable count ends having the number of negative values. Okay, so this is a program. We got to fill in the blanks, and we have to fill it in so it's going to count the number of negative values. So we set the count equal to 0, starting out with 0 negative. We don't have any negative values yet. Read in the first one, and then we test if the value is not 0. Okay, I guess we're going to read until 0. So if we're going to read in digits, or we're going to read in values until we hit a 0, and once we hit a 0, we're done. Okay, so by the way, in looping terms, a loop which terminates based on a particular kind of input, that particular kind of input is called the sentinel. And so, of course, the data itself cannot have a sentinel value. And sentinel values are often 0 or 1, or minus 1. And there's other, when we're looping and reading and other things, there is other kinds of sentinel values. But so there always has to be inside the condition, or inside the loop, there's got to be something that happens that will eventually happen that will cause the condition to be false, because otherwise you end up in an endless loop, which of course you don't want. Okay, so in this case, while the value is not 0, I'm going to sneeze. Excuse me. So while the value is not 0, we're going to, if we're adding up the number of negative values. If value is less than 0, then we want to increment the count value, count variable. So what should expression A be? Well, it should be if the value is less than 0, then increment the count, which is statement B. B, increment the count. If the input value is 0, does the loop body execute input value? So there is an input here. If it's 0, it's no, it does not. All right. Find the max. Oh, here, find the max value. Okay, so here we have to have. Okay, here we have to test the input value with the stored value. If the input value is greater than the stored value, then we want to replace the stored value with the value that we just input. Otherwise, we want to just read the next one until we hit the Sentinel. So let's try this. Yeah, that's bigger than that, so we want to store it. What's next? Oh, that's bigger. We want to store it. What's next? That's bigger. We want to store it. What's next? That's bigger. We want to store it. What's next? Ooh, that's not bigger, so we don't want to store it. That's bigger, so we want to store it. That's not bigger, so we don't want to store it. Are we done? Still moving. Oh. Okay. All right. Was I supposed to do that? Oh, yeah, I was supposed to do that here, too. Okay. All right. Very good. So here, same kind of thing. So here we're starting out setting it to a value that it'll never be. And that way, the first one that's input is going to replace that value. And then after that, we're good. So if we were to start out with this value being some number, and every value we read in was smaller than that number, and we're looking for the maximum, we aren't going to find it because we already have the maximum, which was what we set it to originally. All right. So anyway, let's see what's next here. Oh, okay. So while loop. So now we're basics of the while loop. So we start out with an expression, or there's some variables that are set or whatever, and then while the expression is true, then do this, and then after that we go back up to the top again and we test the same expression again. So something had to have happened. Okay, so the expression has got to change sometime. The loop keeps looping, and the expression has to change. Eventually, the expression has to change in a way that it's going to evaluate defaults, so the loop ends. By the way, you might notice that this is exactly the same thing as an if statement. It's same thing. If the if is true, you execute the body of the if, the then part. It's just that with a while loop, you actually go back again and you test again. Whereas with an if, you just either, if it's true, you do it. If it's not true, you skip it. So in this example here, what are we supposed to do? We're supposed to let's just run it and see. Execute that. While it's equal to y, while the character is equal to y, we print it. Oh, yeah, we print it, and then we multiply the current power by 2. So this is figuring out 2 to a power. 2 to a, so like if y is okay, let's just run it. 2 multiply by 2, read another one. It's y. It is y, so we do that again. It is y, so we do it again. Now it's not y, so we skip it. All right. How many times will the loop body execute? See, here's that off by 1 thing. All right, so start out with 3. Is 3 greater than 1? Yes. So it loops. Subtract 1. Is 2 greater than 1? Yes. Is 1 greater than or equal to 1? Yes. Is 0 greater than or equal to 1? No. So it's going to be 3 times, I believe. Yes, okay. But you can see this is an example of where you can be off by 1. It's easy to end up being off by 1. Like if the example of an off by 1 error would be if you wanted the thing to do 3 times, but you forgot to put the equal sign here or something, then it would only be 2 times that it would loop. All right, so here we talk about the Sentinel value. Here the Sentinel value looks like it's Q. So we read in Q for quit. This makes sense. So we read in characters until we read in a Q, and then we quit. Iterate while x is less than 100. While x is less than 100. X is less than 100. Iterate while x is greater than or equal to 0. While x is greater than or equal to 0. Iterate while c equals g. C equals g. Iterate until c equals z. So while c is not equal to z, we iterate. Once, if ever c should become z, and then finally when z does end up being z, then we stop. So while c is not equal to z, all right, in this one, it looks like we are first modding. Oh no, we print out. Oh, we are printing the lowest order digit. Okay. So here we read in a number, and then we print out each digit. One at a time. This is kind of a dumb example, but this is the kind of code that you use to convert like really low level programs that are reading the characters that the user types in. So let's say you're reading in one character at a time, and you're reading in a bunch of digits, and you want to When you're done reading all the digits, you want at the end you want to have the actual value, the integer value that you just read in. So you're reading in characters. You're reading in characters that represent digits, and then you can do this loop kind of thing where each digit you read in, you multiply what you have by 10 and add it, and so this is a similar kind of process, but it sort of is trying to get you used to the idea that uh, where loops are useful, and even in lower level systems programs, there's a program which converts the characters that I type in into a number. If I'm typing in digits, that's in the lowest levels of your computer. That's we do that all the time. So anyway, that's a pretty good example. Let's okay, this is kind of a dumb example where uh, you're kind of computing the number of ancestors that you have, and you're making some assumptions here, um, assuming approximate ancestors to in considered year. Okay, so let's say right now in 2020, you have two ancestors, and a generation is 20 years. That's pretty low number for generation. Uh, but anyway, so and then you read in a year, and which is a year in the past, and you this estimates how many ancestors you might have in that year. So I don't know, whatever. Here the person, or here you enter in 1945, and it figures out from 2020 you have two ancestors because that's what you start with, and then each time you go back, you multiply times two because it's two ancestors per um, generation, I guess, and so you end up with this. Anyway, that's kind of a dumb example. Okay, let's basically what I'm trying to do here is just you're going to do all these exercises, but uh, I want to just kind of get you started so you realize what they're asking, and then you can, once you know what you're asking, it's tough to answer a question that where you don't understand the question. So that's what I'm trying to do here. Okay, so what do these look like? What is the output of the following code? Okay, so we start out x equals 0. While x is greater than 0, print x. And don't print a return, just print x followed by space. Subtract 1 from x and loop again. And so what this is going to do is, well, this is not going to execute at all. X is equal to 0, and while x is greater than 0, do something. Well, it's not greater than 0. So we skip all this and just do this down here. And so what's the output of the code? Well, it's just the by. Here it is. We started with y equals 5. See, why don't I do my I'm gonna pop this up. So I got some space to write with. Make it smaller. All right, so got my new pen here. Got on Amazon. Nice. So we start with y equals 5, and x equals 5, y equals 18. So the first is x equals 5 and y equals 18. And the first one is y greater than x. Yes, y is greater than x. Y is 18, y is greater than x. So we print y. We print 18. and then a space. And then we say y equals y minus x. So now y equals y minus x is 18 minus 5. So y now equals 13 minus 5. 13. So we loop back up around. Is 13 greater than or equal to x? X is still 5. Yes, it is. So print 13. 13 space. Come down here. Y equals y minus 5. So let's subtract 5 again. And we get y equals 8. Come back up here. Is 8 greater than or equal to 5? Yes, it is. So we print 8, followed by a space. And then we subtract 5 from 8, minus 5. And y now equals 3. Is 3 greater than or equal to 5? No, it's not. So we skip the loop, and we're done. All right, I'm going to try something. I'm going to try to remove this ending space. I'm going to try to remove this space and see what happens. All right. Well, anyway, note that there is a space after each number, including the last number. Psh, junk. All right, what's this one? X equals 10 while x is not equal to 3. Well, that doesn't look like that's going to work out very well. Let's see. Let me erase this. Clear canvas. Okay, start out x equals 10. And while x is not equal to 3, okay, x is not equal to 3, so print x, print 10, followed by a space. And then we're going to say x equals x divided by 2. So now that is going to be x equals 5. And so we come back around. Is x is not equal to 3? Yes, it's true it's not equal to 3. So print x, 5, 5, space. So we print 5, and then we say x equals x divided by 2. X divided by 2 is going to be x equals 2.5. Come back around. Is x is not equal to 3? It's true x is not equal to 3. So we print the 2.5. And then we space. And then we divide that by 2. And we get x equals 1.25 or some such thing. Anyway, we're never going to we're always going to be not equal to 3. We're never going to equal 3. So this loop is never going to end. So what do? We say IL. 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 Yeah, that's what I'm talking about. All right, so you can do the rest of them. Okay, here's a challenge. All right, let's do some challenges here. Get rid of this. Put it down here. Challenge. Where's the challenge? Here it is. Basic while loop with user input. Okay, so note an expression that executes the loop body as long. Write an expression that executes the loop body as long as the user enters a non-negative number. So we're going to have something that's reading in something that the user is entering, and the user can enter in stuff and then you terminate the loop. You terminate it by entering in a negative number. Okay, I was wondering about that. If the submitted code has an infinite loop, the system will stop running the code after a few seconds and report program end never reached. The system doesn't print the test case that caused the reported message. Okay, so for example, 952 is going to be body, 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 and then when it reads in the -1, it's going to enter a print on a done followed by a period. Oh, so we're supposed to enter our code in here. So what is the expression we put in here? Well, we want it to loop until user number, no, while user number is not, okay, while user number is greater than -1, while user number is greater than -1, do that. Now, I'm going to test it. I'm going to test that thing. So I'm going to do while it's less than, greater than, while it's, I'm going to say while it's greater than or equal to -1. I'm just going to see what that does. Boom. All right. Of course. So let's do an infinite loop. User num is, how can we make an infinite loop here? Well, user num is, while user num is equal to user num, that'll always be true. That'll always be true. Therefore, the loop should go on forever. Let's see what happens. Oh. Well, anyway, it wasn't supposed to work. So anyway, the real answer is while user num is greater than -1. These are integers, right? Can be greater than or equal to 0. While user num is greater than or equal to 0. Alrighty, very good. Basic while loop expression. Write a while loop that repeats while the user number is greater than or equal to 1. In each loop iteration, divide user num by 2 and then print user num. So yeah, it's going to look like this. But while it's greater than or equal to 1. So it's going to input in, so user is going to type in a number, and you're going to keep on dividing it by 2 until we get down to a fraction. Okay, so we have to put our code here. So we're reading it in while I guess we're just going to use user num. We can just use user num. Oh, okay. While user num is greater than or equal to 1, then divide equals user num divided by 2. And we're supposed to print. Oh, we're supposed to print. Do we print first? We print after we do the division. When we read in 20, we don't print until we get to 10. So we print after we do the division. So that is print user num. Okay, this will probably work. And we got to put in some, oh, this is a challenge. Alrighty, very good. Oh, yes, of course. Of course. Okay, very good. More while examples. No questions yet. Very good. This means you're all absorbing it. Either that or you're all asleep. I don't know. I only see myself. So. Oh, that's what I see. All right. I don't want to give away anything. Okay, so greatest common divisor. All right, greatest common divisor. This is a program I think I've talked to you about where you just keep on doing these iterations. In the end, you get the greatest common divisor. You can look at that. Um,
Mr. Halverston, can
yes.
we go over the greatest common divisor,
Oh,
please?
so you want to go over this one?
Yes, please,
Okay,
if you don't mind.
right, good. Okay, the following example is using a loop to compute a mathematical quantity. The program computes the greatest common divisor among two user-entered numbers. So we're going to enter in two numbers, and we're going to use Euclid's algorithm. So, and what Euclid's algorithm is if if the first number you entered in is greater than the second number you entered in, if A is greater than B, then set A to A minus B. Otherwise, set B to B minus A. So you start out um, by taking the bigger number. This doesn't. B equals B minus. Okay, so I see. So you keep on doing that until either num A equals num B. Yeah, num A equals num B, right? So, and if it's 1, it means okay. So, so we read in a num A, we read in a num B, and then while num A is not equal to num B, see, the loop is repeat until num A is equal to num B. Oh yeah,
Thank you.
yeah, I'll finish this. I've seen there's different variations of this, but let's go through this again because once I start explaining this, I always have to get it straight in my head. So if you understand it already, that's great. I just want to get it straight in my head. So let's just go through this code, okay? It's 3:59. Good, we got a half an hour. So while num A is not equal to num B, then we're going to do this. If num A is greater than num B, then we're going to subtract num B from it. We're going to subtract. So we're going to subtract the smaller one from the bigger one. Subtract the smaller one from the bigger one. Oh, I see. Oh, I see. So we just keep on looping, subtracting the smaller one from the bigger one, and then we test it again. We test test if they're equal again, and if they're not, we just subtract the smaller one from the bigger one. We keep on doing that until finally we end up with we should end up with where they're equal. Now, why does that work? Um, oh, if you always subtracting the smaller one from the bigger one, it'll never go negative. Oh, it'll only go to 0 while they're both. Oh, see, it's this terminating condition. It's hard for me to actually see that terminating condition. Um, well, the thing about programming is that if you're unsure, just run it with a few examples. Let's see what this does. So the greatest common divisor is 5. here, right? Because I mean it's not 10. So we start out by going subtract 15. Let's pop up our little screen here. So 20. So we have 20 and then 15. So we subtract the smaller. Oh, we subtract the small. Okay, so this is gonna. So let's just call this one A and this one B. So here we're gonna subtract the smaller from the bigger. So we're gonna do A equals A minus B, because B is smaller. I'm gonna subtract that. So after this now, A is gonna equal A is gonna equal. It's still gonna equal. Oh no, it's gonna equal 5, because 20 minus 15 equals 5. So now A is equal to 5. B is still equal to 15. B is still equal to 15. So then we subtract the smaller from the bigger. So now this time we're going to subtract B equals B minus, the smaller one is 5. A is 5. So anyway, 15 minus 5 is 10. So now B equals 10. And A still equals 5. B equals 10. We subtract the smaller from the bigger. So we're subtracting A from B. So B now equals B equals 5. So we're subtracting A from B. So B equals B minus 5. So now B was 10. So now B equals 5. And A still equals 5. And so now we have, so now we've hit the case where num A this is false, because they're the same. This is the same as this. So then we're done. And so 5 is the answer. Okay, so yeah, so we always subtract the biggest from the smallest. No, we subtract the smallest from the biggest. We keep on doing that until we end up with two numbers that are the same. And if and it and it may be that it ends up being 1. And in case it's 1, then they're called relatively prime. All that. Okay, so anyway,
Thank you.
welcome. Very good. Well, that's an easy version of that algorithm. Are we going to get into recur? I don't think we're going to get into recursion, but this is a great algorithm for um, showing all kinds of things. Okay, so so this helps you understand it. The value of num A before the loop iteration starts out here. It's 15. Well, anyway, you can go through this. How many iterations does the algorithm execute? 5 and 10. It would be what is it? It's 10 and 5. So the first 15 and 5. So the first one is where num A becomes 5, because we're subtracting 10 from 15. So num A becomes 5, and then num B becomes 5. Is it 2? Is it 2? Oh, right. Okay, great. All right, so while loop example, conversation. Oh, this is one of those. Well, you can look at that one. Let's get some, where's some challenges? I want to do some challenges. Okay, here's some challenges. Challenge, while loop with Sentinel. So in this example, we are we enter a value, we set that equal. Oh, we're finding we're figuring out the largest value of a bunch of numbers that were entered. Okay, so we read in a number, and we start out by setting that as the maximum value of what's read in, and it is, because only one thing is read in, so the maximum value of the ones read in is the one that was just read in. And then we're going to go through this loop until the user enters in a 0 as the which means we're done, which means we've entered in all the values that we're going to enter in. So tell me what the biggest one is. So is the entered value greater than 0? Yes, it is. So then we test if the entered value is greater than the maximum value, and if it is greater, then we set a new maximum value equal to the entered value just read in. And then we read in a new entered value, and we go back around and we loop again. Okay, and at the end, max value is going to be set. The test will have occurred on every entered value, and we'll end up with the maximum value. So what are we supposed to do here? Let's start, and we're supposed to say, okay, this is the input. We're just supposed to say what the output is. Well, it's 34. So I'm supposed to do. Oh. Oh, are we just executing this? What am I supposed to be writing out here? Am I supposed to say 2? Well, this is the input. I don't know what I'm supposed to do here. Oh, never mind. I'm supposed to see what I'm printing. Printing. Output. We inputted 2. Maximum value is 2. Is 2 greater than 0? Yes, it is. So is 2 greater than 2? No, it's not. So read another one, and that's 34. Oh, I know why. Max value colon space 34. All right. You got to understand the question before you give the answer. Okay, so next, what am I supposed to do here? Oh, okay. Oh, this is a sum program. So we're looping. Oh, I see. We're testing sentinels. Okay, so the sentinel is going to be, it's got to be greater than 0. So this is going to be the sentinel here, and we're supposed to the final sum, and we loop, adding them all up. Each time we read in a new one, so the final value is sum colon space 9. Yeah. Very good. If the current age is less than 16 or greater than 30, then we do something. Otherwise, we're done doing things. So the first time we read in, is the current age less than 16? Yes, it is. So this executes. Is the current age less than 16? Yes. So we output very young. enter, perfect match. We're always going to write that. That's weird. All right, bidding example. Write an expression that continues to bid until the user enters an N. I see. All right. Okay. Okay. So we just need to put in the terminating condition. User enters an N. I see. So this is the beginning, and so while keep going is not equal to N, right? N. While it's not equal to N, then so the user, so we're not going to test if the user enters in a Y. We're only going to test if the user enters in an N. The user either entered an N or did not enter an N. So uh, so that's what the answer should be, I think. Let's see. Very good. While loop, insect growth. Okay, here we're just multiplying by 2 all the time. Tell you what, I'm gonna switch to a. I'm gonna do the first lab. Why not? So let's go here, and let's just. I gotta remember where I ended. I ended. Let's go back. I want to finish this unit here. Then I'll go. I got 13. Okay, so let me finish this page here. Then I'll go and do my So let me do that, and I'll start with counting next time, I guess. Okay, so given positive integer num insects, write a while loop that prints then doubles num insects each iteration. Print values less than 100, followed by a space. So we go until we get a value. We go while a value is less than or equal to 100. So we only do this while our computed value of num insects is less than or equal to 100. So while num insects is less than or equal to 100, then double it. Num insects equals num insects times 2. Yeah, I guess it's times 2. Oh, we got to print it. We sample output with input of 8. Oh, that means we got to print before we compute. Print num insects. Follow each number with a space. End equals space. Let's see if this works. All right. Okay, now we can go to, let's go to lab. This one is a while, right? Yeah, it is. This one's a while. Convert to binary. Convert to binary. Write a program that takes in a positive integer as input and outputs a string of ones and zeros representing the integer in binary. Okay, so we've got to divide by 2 a bunch of times. Okay, for an integer x, the algorithm is, as long as x is greater than 0, output x modulo 2, and then divide x by 2. Keep on doing it until x is not greater than 0. Right. It should be an integer divide, I guess, also. So we start out with 6 modulo 2. Wait a second. This is reversed. Oh, yeah, it's reversed. Wow, that's interesting. Okay, so it printed out backwards. 6 modulo 2 is 0, and 6 divided by 2 is 3. So we got 0 here, and then we end up with 3. 3 divided by 2, or 3 modulo 2 is 1. So it's a 1 here. And then 3 divided by 2 is 1. It's 1 with a remainder. 3 divided by 2 is 0 with a remainder of 1. Right? 3 divided by 2 is 1 with a remainder of 1. So the 1 goes there, and then, well, let's write the code. We are reading in a number, so I got to read in a number first, and I'm going to call the number x. X equals int input something. Do I have to? Don't say anything. I'm going to say enter a number. So I might have to take that out to get it to work at the end, but let's put that there so I know what's. Oh no, never mind. If I were running this on my own little system, I would do that. But since it's this crazy nutty thing, I'm not going to do that. Forget it. Okay, so I take an input, and then I say while x is greater than 0, then print. What happens if I print x mod 2? Mod 2. Can I do that? I think that works, doesn't it? End equals. Oh, no, nothing. X equals x divided by 2. Does this work? 6. Let's try 6. So that's 6 is 110. Let's see. 20, 32 is 1 1. No, 31 is 1 1 1 1 1. So 30 must be 1 1 1 1 0. 30. You could do something like this, and it would actually print out right correctly. I'm going to say y equals. Then I'm going to say I'm not going to. I'll leave that there, but I'm going to say y equals, so I want to print it out in reverse. So I don't want to append it at the end. I want to append it to the beginning. So y equals string of x mod 2 plus y. So what I'm doing in my loop is I'm creating another variable called y, and I'm going to create the binary number, but I'm going to make it in the correct order. So each time I get a new digit, I'm not going to append it onto the end, which is what this program does now. Instead, it's going to append it onto the beginning. I'm still going to do this printing stuff out here, but what I'm going to do is at the end, I'm going to say print y. And you'll see that. You'll see this now. Oh, I gotta print this out. Okay, I gotta do a print. Okay, so let me just run this. Okay, see? So this reverses it. Let's put 6 here. See, so all I'm doing is this one is this where I computed a y. But anyway, this will not be the right answer. I cannot have this in, no, I can't have any of this. It should still work now. This should be an acceptable answer. I'm going to try to submit it. Am I supposed to have that thing at the end? Sorter. I guess we should not print it out this way. Let's make y be. Let's do this. Let's y plus this, and let's take this out of here, and right here let's print y. This is probably the right answer. Yeah. Okay. So it actually wants you to build the string. Here we're building the binary number to print out, and we're actually building it in reverse order. We didn't have to build it in reverse order. We could have done this. Could have done this instead. In which case it would print it out in the correct order, but it doesn't. It's printing it out. See, everything's reversed and goofy. See, that's really how we should print it out. And I don't know why they didn't make that the problem. But anyway, you know how to do this one now. Looks like that. All right, so so what's another one? I got 5 minutes. Where's another? This up here. 14, 15. Oh, this is pretty cool. All right, let's look at 516. Password modifier. Many user-created passwords are simple and easy to guess. Write a program that takes a simple password and makes it stronger by replacing characters using the key below, and then by appending Q asterisk S at the end. Okay, that's pretty nice. Okay, so lowercase I becomes that, exclamation point, a lowercase a becomes an @ sign, a lowercase m becomes a capital M. Ooh, that's clever. A B, capital B becomes an 8, and an O, no, it's a lowercase o, it looks just like this O here, becomes a period. So in other words, that. This becomes capital, this becomes an @ sign. Well, they should make S's become 5s. This becomes a period, and then we add this Q asterisk S on the end of it. Okay, so we read in a word and we build a password. Okay, so we have a loop which loops through the length of the word. Okay, so we got we got the input, and then we're going to start out by we have to have a, yeah, this is where we could really use a while loop, but we'll start out with I = 0, and this is going to be an index into the word that we typed in. So we're going to type in something, and then take that word, and we're going to go each character at a time. So while the I is less than the length of the word, while that's the case, do this. If word, and this is how you reference, you would call this, this is how we would reference the 0th character of the word. If that's equal to an I, that's equal to this, then we want to password, we want to append onto password this. So if the character, we're starting out with I = 0. If word of 0, if the first character of the word that you typed in is I, and we're going to do the same thing for all the characters. Okay, so we're starting with the 0th one. We're going to go all the way up to the length of the word, and we're going to execute the same code each time. So this is if that is the case. Otherwise, elif word of I. Now this is I, the index. Confusing. Let's not use I. Let's use N. Let's use N. Just so it's not confusing. Although that might have confused you. So if word is equal to, what's the next one we got to care about? A. If it's equal to lowercase a, then we want password. Then we want to append an amper to this thing. And then we want to and we got M, B, and O. M, B, capital B, and lowercase o. And the lowercase m becomes an uppercase M, and a uppercase B becomes an 8, and a lowercase o becomes a period. And so we're going to do this O. And if it's none of them, if it's none of those things, then we just want a password. We can just add append on what that character was. And then when we're all done with that, we go on to the next word. This is an N. I'm using N as my loop variable because I don't want to confuse it with this or whatever. It's probably not confusing. Okay, so then, so now we do N plus equals 1. And we could have done N equals N plus 1, or we can do N plus equals 1. Same thing. And so this is going to keep on going until N is equal to the size of word, which is 1 character past the last character of the word. And is that it? Oh, we got to stick that password.qs thing on. Q asterisk S. Stick that onto it, and then we print out password. Now, what happens if I do an off by one error and I do this? Let's see what happens. I'm going to run it. Oh, it requires some input. I'm going to say I got to have some M. I want to have an I and an A and an M and a B. M, I, 1, 2, 3, B, B, O, whatever. A. All right, what does this do? Oh, the reason for that is because it's out of range. So that's what I do. So I had an off by one error, and this displays that out. So this got converted to a capital. This got converted to an exclamation point. The 1, 2, 3 stayed. Nothing interesting there. The capital B turned into an 8. The O turned into a period, and then the lowercase a turned into an ampersand. And then this Q asterisk S gets attached onto it. So I think this will probably be enough. All right, so I hope you followed that. It's 4:33, and so I covered while loops, and so this is. I'm going to do a little bit more on while loops tomorrow, Thursday, because we didn't. The next section is still a little bit more while loops. But if you didn't understand anything, if there's anything you didn't understand, then let me know, and I want to go back and emphasize, and I'll go back and emphasize the parts that were confusing. So how does that sound with everybody? Are there any other questions? Okay, say one thing I want you to think about is there is this programming activity called paired programming, and the way it works is I assign you to I take two of you together, you go into a breakout room. I'll do these breakout rooms, and you decide and you work on problems together. Okay, so two of you sit and one person types, or no, one person. Actually, we'll have to do some variations because you actually are apart, and you're both going to hand it in. So you both are at your keyboards, and you both can type the same. You both type the same thing in basically, and you talk to each other, and one person, if one person can lead and the other person can just type, and come to the you come to the solution together, sort of bouncing ideas off each other, and that's been found to be a uh, very good way for students to learn, and it's got all these other features like any sort of inherent difference between like somebody who might be you know bossy and like telling the other person what to do, or one person is meek and mild mannered. If one person is assigned to do the talking and the other person is assigned to do basically the typing, then all of those problems that can occur when in teams sort of go away. And it's a good way for each of you to sort of see how the other person is thinking and see maybe where your thinking is wrong. So think about that and think about how we would want to assign those. I'm going to have to get others, get some of the others that don't come to class every day to we have to get their input. And so I may have a couple of assignments like this. I'll probably have a couple of assignments like this, and you wouldn't have to do it in this class. You can do it some other time, and uh, basically, you work until you get them both, until you get the right answer, and then at the end, I'll probably going to ask you how it went, and because it's supposedly the new sort of a new way uh, when you're trying to be more inclusive and diverse in your classroom and all that. So anyway, that's all I have for today. If there's any questions, I guess I'll end the class. Are there any questions? All right, very good. I will see you on Thursday. Thank you.
Thank you.